put a case there. I have one F1 there, and then I have F1 here in one direction at some distance D1 from point O. I have F2 at some distance D2 in the opposite direction. I just put some random forces there. So what we want to know is that, well, informally, you want to know what happens if you have more than one force, right? In a system of forces we're dealing with. But officially, we look at it as a resultant moment, right? We said resultant is a fancy word of finding the vector sum of vectors, or sum of vector quantities. So resultant moment of I forgot to pin the video. So the resultant moment of a system of forces, let's be more official, of a system of forces, and obviously this is just in two-dimensional. Now what we do, well, let me pick the one. When we have all the forces lie in one plane, obviously, we are in two-dimensional. The resultant moment is pretty much just finding the algebraic sum. Take one direction as positive. Typically, the convention is we take counterclockwise as positive and clockwise as negative. And that's what I follow in this course and for the rest of the course, but for the rest of this course. But as long as you know that one direction is positive and the opposite of that is negative, and make sure that you are taking care of the signs, you are good to go. You can just say, well, I took this as positive direction and this is the moment. My suggestion is always go with the sign convention. Right? So let me just put a few words. The resultant moment is let's put it this way. Do I have a better wording there? Is the, let's say, algebraic sum of the moments. You can just make it a little more fancy, caused by all the forces. All right. So what I'm trying to say, well, let me put the sign convention first. So sign convention, I'll take counterclockwise to just follow the book. Counterclockwise as positive, meaning that this is counterclockwise, positive. And I'll take clockwise, right, as negative. This is negative. So looking at these three, for instance, right, F1, in this direction, palm of my hand towards the point O, this is the direction, so that's positive. So F1 creates, in this case, let's say I want to find the resultant moment, would be F1 D1, and it's in counterclockwise, so it's positive. We'll go to F2. Oh, F2, the direction, palm of my hand towards the point, creates a moment in this direction, which is clockwise, so it's negative. It's minus F2 D2, and then F3, right? This way, create a moment, positive direction, plus F3 D3. Right? Just keep going, depending on how many forces do you have, and you know the perpendicular distance from that force to the point you're finding a moment about. You just keep going and find the resultant moment. Now, in general, right? Let's put it in general form. In general, when you have multiple forces, you have resultant moment, right, would be summation of all the moments, I'll call it this way, I put it this way, from 1 to n being the number of forces you have in that plane. So this is, right, this is M1, this is M2, this is M3, etc. So you can actually write this way, I from 1 to n, Fi di. And n being the number of forces again. And so this is the general procedure, or general form, I would say, to find the resultant moment when you have more than one force.